The Hoover Dam is 221 meters high with an area of 694 square kilometers, right? So I'm going to assume, by the way, that the water is 221 meters deep everywhere in the impoundment area, right? This is a big rectangle. And so estimate the mass of the water in the dam. Well, that's going to be, let's see, a square kilometer is 1,000,000 square meters. Is that right? A square kilometer is 1,000 meters by 1,000, right? So that is 1e6 square meters, right? Okay. And so I do believe the volume of water behind the dam, the volume is going to be 221, right, times 1 times 10 to the 6th square meters per square kilometer, right? And then I'm going to say that's times 694 square kilometers, right? And then we'll have, let's see, square kilometers will go the way of the bison. We'll have square meters times meters, which gives you cubic meters, right? So the cubic meters of water in this dam, and I'm sorry I'm swearing so much on this one, right? It's necessary for my pedagogic technique. Okay, so 221 times 1e6 times 694. Okay, boy, that's a lot of water. I don't even know what that number is because my stupid TI calculator will not put it into scientific notation automatically. Okay, that is the volume of water is 1.5337 times 10 to the 11th cubic meters of water, right? Now, the mass of water in the dam is every cubic meter is 1,000 kilograms, right? Okay, so that is why it is not 10 to the 11th kilograms. It's 3 more powers of 10, right? If I multiply that out. Okay, so storage A times 1,000. And so 1.5 times 10 to the 14th is what I get for the mass, okay? It's actually 1.5337 times 10 to the 14th, okay? That's kilograms, that's just the mass, right? And then how much potential energy is stored in this water? And I think the trick there is that we're going to use MGH, okay? Use MGH. But the height that we're going to use is half of 221, right? Okay, because on the average, the water is about half as high as the highest height, right? If you got a dam here. Sorry, I'm swearing so much, right? Okay, you know, this is half the height, and half the water is above that, and half's below, right? So we're using an average. Okay, so that's going to be 1.5337 times 10 to the 14th kilograms times 9.81, right? And then I'm going to go 221 meters over 2, right? Okay. So I'm going to go that times 9.81 times 221 divided by 2. Half of 221, right? And I get 1.66258, right? Okay, times 10 to the 17th joules, which would really be 1.7, right? So IB does that. They like use rounded answers, which is wrong. Isn't that wrong? I think that's wrong. Is that wrong? Let me see if that's a typo. No, it's not. They have the wrong answer in the book. Okay, so it can produce 1.5. See if what's the question? The Hoover Dam is 80%. How much PE must be lost per second from the water to produce this power? That's the question, right? Okay. How much PE must be lost to produce? So the question is, does it say in an hour? Per second. Okay. So we want to know if it's 1.5 times 10 to the 9th watts, right? Basically, the question is, what is the power input if it's 80% efficient, right? Okay. So for C, I'm going to say that efficiency is power output over power input, right? So therefore, power input is power output divided by efficiency, right? So that's going to be 1.5 times 10 to the 9th, and that's of course joules per second, right? Divided by 0.8. Okay. Let's store that in B. Okay, so let's go 1.5 e to the 9th divided by 0.8 gives us 1.875 E9, and that's joules per second, right? Okay, so that's this answer here, right? For C. That's how many joules we have to, potential energy we've got to pump into that thing, right? And then it says, what mass of water must flow through the turbines each second to produce this power? I think for this one, we assume that the mass is coming from that height of 221 meters, I do believe, right? And the question is, how much mgh do we need? That's a good question, right? So we want to create 1.875 times 10 to the 9th joules. Right, that's going to be the energy, right? And then that equals, good morning, Tualatin High School. Okay, and then that's mgh, right? Okay, so that's going to be m times 9.81, right? And then times the height is 221. We'll find out quickly if I've got the right answer here, right? Okay, so I'm going to divide this answer by 9.81, and then I'm going to divide by 221, right? And I get 8.6 times 10 to the 5th. 8.6 times 10 to the 5th kilograms. Okay, so they say that the answer is, and this is let's see, 13. They do say 1.7 times 10 to the 6th. I do believe that's the answer we would get if we divided by 1.875 E9th divided by 9.81 divided by parentheses 221 divided by 2. Okay. Yeah, if you use half the height, okay, if you use half the height, then you get that answer. So the question is, which do you use? And the answer is, I'm right and they're wrong, okay? Because if you have a dam and the water stays at that level, right, the water coming out of here, okay, the water coming out of here is as if it came down through the entire 221, not through half, okay? I am 100% sure that I'm right and that they're wrong. This is not uncommon for these textbooks to be incorrect.